Hello, and welcome to this lesson on the properties of ionic compounds. In today's lesson, we will firstly learn to describe melting and boiling points of ionic compounds. We will then examine the electrical conductivity of ionic compounds in different states. Finally, we will discuss the state of ionic compounds at room temperature. We've already discussed ionic bonding, visualized through dot and cross diagrams, and represented through ionic equations. You also understand the 3D lattice structure of ionic compounds, which illustrates their arrangement in a solid form. Building on this foundation, today's lesson will advance our chemical understanding by delving into the specific properties that result from ionic bonding and lattice structure. This will deepen our insight into why ionic compounds behave the way they do, and how these properties are related to their underlying structures. Let's get started. Let us start by discussing the melting and boiling points of ionic compounds. Ionic compounds typically have high melting and boiling points compared to molecular compounds. This is because the strong electrostatic forces of attraction between the positively charged cations and negatively charged anions in the ionic lattice require a significant amount of energy to overcome. Picture a lattice as a 3D grid where each ion is surrounded by ions of the opposite charge. This strong bonding keeps the ions in place, and thus a high temperature is necessary to break these bonds, resulting in high melting and boiling points. For example, sodium chloride, table salt, has a melting point of around 801 degrees Celsius and a boiling point of around 1413 degrees Celsius. These high temperatures are needed to provide the energy required to break the ionic bonds holding the ions together in the solid state. Ionic compounds exhibit interesting behaviors when it comes to electrical conductivity, and it varies with their state. In the solid state, ionic compounds are poor conductors of electricity. This is because the ions are fixed in their positions within the lattice structure and cannot move freely. So, even though they contain charged particles, they cannot carry an electrical current. When an ionic compound is melted, the rigid lattice structure breaks down and the ions are free to move. These mobile ions can carry electrical current, making the melted compound a good conductor of electricity. Imagine the ions as athletes who were once in tight formation, now free to run around when the formation breaks. Similarly, when an ionic compound is dissolved in water, the water molecules surround and separate the ions from the lattice, allowing them to move freely in the solution. This mobility of the ions in the aqueous solution enables it to conduct electricity effectively. For instance, when table salt dissolves in water, the Na+ and Cl- ions move freely and conduct electricity. Lastly, let's discuss state at room temperature. At room temperature, most ionic compounds are in the solid state. This is a direct consequence of their high melting points. The strong ionic bonds firmly hold the ions together in a crystalline lattice, making them solids under normal conditions. An example of this is again sodium chloride, which remains a white crystalline solid at room temperature. In today's lesson, we delved into the properties of ionic compounds, focusing on their melting and boiling points, electrical conductivity in different states, and their state at room temperature. Understanding these properties allows us to predict and explain the behavior of ionic compounds in various scenarios, linking their macroscopic characteristics to their underlying atomic structures.